Good afternoon. So I'm just going to take you through my course assignment for power plant modelling for my machine learning module. So what's the overview? What we're looking to do is develop a predictive model for the net hourly and electrical energy output of a combined cycle power plant using environmental variables collected from sensors. We've got 9,568 observations, including the temperature, the exhaust vacuum, the ambient pressure, and relative humidity. And the target variable is the net hourly electrical energy outputs. So what's the approach and the evaluation metrics? Since we're looking to predict a continuous numerical value, this is a regression problem. Suitable evaluation metric for this problem is root mean squared error, and it also provides a direct measure of how far our predictions are from actual values, and it also penalises large errors more heavily. So we're going to use the below variables as input features, so temperature, exhaust vacuum, ambient pressure, relative humidity, and we've considered the linear regression, which is basically a baseline model due to its simplicity and interpretability, and also the random forest regressor, which is a more complex non-linear model that handles features interactions well. So the chosen strategy is we compared fixed validation versus cross-validation. We decided to go with fixed validation because it's simpler to implement, it's faster to run, a large data set, and it also allows us to train 80% and test 20% of the data. So what approaches have I taken? So the approach one was to run the regression in Excel with 80% of the data. So when I run it, we're getting an R squared of 0.923. The significance is 0, and that's significant because it's less than 0.05. And when having a look, we can see that the least coefficient is the 80. So for approach 2, what we're going to do is run the same model again, training model again, but without 80. And this gives us an R squared of 0.803. Again, the significance is less than 0, so it is a significant test. So what happens when we test it and we evaluate it? So when we run both approaches on the remaining 20% of the test data, we can see that on approach 1, we've got the R squared of 0.925, and on the second approach, we've got 0.808. So the approach that I would choose is the first one with all the data, because the R squared is closer to 1, so therefore it's more relevant. And yeah, that was my conclusion, really. Thank you.